Hello, and welcome to this video on the difference between permutations and combinations. We're about to learn about two different ways of counting arrangements of certain objects, permutations and combinations. But before we get into that though, I thought I'd make this video to stress the difference between the two. Now, I know you haven't heard about these yet, but when trying to determine whether or not you're solving a permutation or combination problem, you need to ask yourself a very important question. Does the order matter? Put yourself into the context of the question and see if it does. If you're looking at, say, license plates and how many arrangements you can make of the different license plates, ask yourself, does it matter if I use the same letters in a different order? Will I get two different license plates? Or if you're choosing lotto numbers, does it matter if you choose the same order that it comes out in on TV? Well, let's look at an example. Let's say 6 people are running a race, and we want to know how many different ways first and second can be awarded. We're going to give them a name, but for short we'll call them A, B, C, D, E, and F. What I'm going to do is I'm going to list all the possible combinations of first and second in a very systematic way. First, I'll list all the possibilities if Albert comes first. So if Albert comes first, then Ben can come second, or Connie can come second, or Doug can come second. Any of the other people can come second as long as Albert comes first. Then I'll do the same for Ben, and then Connie, Doug, Edward, and Francine. These are all the possible combinations. There are no other possibilities. Now, by counting them up, I notice that I have 30 different arrangements. So I ask myself, or at least I should have at the start of this, does the order matter? If Ben comes first and Connie comes second, is that the same thing as Connie coming first and Ben coming second? Well, you see, it does matter who comes first and second, so these two are different. This makes this a permutation question. Now, I know you don't know what to do with that yet, but in the future it'll make a lot more sense. Let's look at one that looks only slightly different. 6 people again are trying for a doubles tennis team. We want to know how many different teams are possible. Let's look at the similarities first. I'm looking at a different combination of pairs, and there are 6 different people to choose from. We're going to use the same 6 people. Now, if I choose Albert first, these are all the partners that he can have. It may seem obvious, but notice that there are no double ups. That just means that you can't have a doubles team all by yourself. Now, these are all the teams that I have when I choose Ben first. Notice that I have 2 teams so far that have Albert and Ben in them. Ask yourself, does it matter what order I pick them in? Here are all the other possible arrangements for the rest of the players. You might be able to see a lot of double ups in there. Because the order in which I pick my doubles team doesn't matter, I have to not count the teams that are double ups. This is an example of a combination question. So we go through and cross off all the doubles in a systematic way. Now, we can see that we've crossed off half of our arrangements, and while the rule is not just to halve your answer, we will learn the rule later, we can see that our answer is going to be a smaller number than what we started with. We have 15 different arrangements or combinations. Let's summarize our differences. In permutations, the order matters, so we'll get larger answers because we include all the arrangements. The number plate at the example at the start of the video is a permutation question because ABC123 is a different license plate to CBA321, even though we use the same letters and numbers. Phone numbers are another example of a permutation. You can see these 2 phone numbers up here are 2 completely different ones, even though I'm using the exact same numbers. With combinations, the order doesn't matter, so we need to exclude any combinations that uses the same items just in a different position. The lotto example at the start of the video is an example of a combination problem. You'll win even if your numbers come up in a different order to the ones up on the screen. Also, when you're choosing teams, the order doesn't matter when choosing them, so these are combination questions. Another way to remember which word means ordered and which one means unordered is with the word permutation. It begins with a P. Now that P is made up of an O, which is the same as ordered. That's one way of remembering it. See if you can come up with your own. Good luck.